On January 27, 1967, 3 astronauts were sealed inside a metal capsule atop a rocket at Cape Kennedy, preparing for America's first mission to the Moon. The test was officially designated non-hazardous. There was no fuel in the rocket, no pyrotechnics were armed, and the spacecraft was not going anywhere. Yet, in a matter of seconds, a single spark would turn that capsule into an incinerator. The last words heard from the crew were choked cries of, "We've got a bad fire! We're burning up!" By the time ground crews could wrench open the hatch, it was too late. The truth is, the Apollo 1 fire was not a freak accident. It was a catastrophe born from a cascade of lethal design flaws, institutional arrogance, and ignored warnings, a tragedy that had been predicted by the very men it killed. This is the dark truth of how the race to the Moon began, with a fatal fire on the ground. In the intense, high-stakes environment of the 1960s space race, the Apollo program was America's answer to Soviet dominance. But the machine intended to carry men to the Moon, the Block 1 command module, was a source of deep concern for the astronauts who had to fly it. No one was more vocal than the mission's commander, Virgil "Gus" Grissom, a veteran of both the Mercury and Gemini programs. He and his backup, Wally Schirra, saw the spacecraft, built by prime contractor North American Aviation, as a sloppy and unsafe machine, plagued by low standards and poor performance. By the fall of 1966, hundreds of technical issues remained unresolved. The spacecraft was riddled with problems: a faulty environmental control system, leaking thrusters, coolant glitches, and dangerously inadequate wiring. When the spacecraft was delivered to NASA, it arrived with 113 significant engineering orders still not completed. After delivery, another 623 changes were ordered. The training simulator couldn't keep up with the constant modifications, frustrating Grissom to the point that he famously plucked a lemon from a tree near his home and hung it on the simulator's hatch, a clear, silent protest that this machine was a dud. The astronauts' concerns were not just about technical glitches. They were about fundamental safety. They had explicitly worried about the sheer amount of flammable material packed into the cabin, particularly the extensive use of Velcro, during a spacecraft review meeting in August 1966. The night before the fatal test, after running a similar simulation, Wally Schirra took his friend Grissom aside. He hated the Block 1 capsule. "If you have the slightest glitch," Schirra warned, "get out of there. I don't like it." It was a chilling premonition of what was to come. The official name for the exercise on January 27, 1967, was the Plugs Out Integrated Test. It was a full dress rehearsal for launch, designed to see if the spacecraft could operate on its own internal power once the ground support cables, the plugs, were pulled. Because the Saturn 1B rocket beneath it was unfueled, the test was considered non-hazardous, a routine step on the path to flight. At 1:00 p.m., Grissom, senior pilot Ed White, and pilot Roger Chaffee entered the capsule. Problems began almost immediately. Grissom reported a strange, sour buttermilk smell in his suit's oxygen supply, causing a lengthy delay while technicians investigated. Unable to find a cause, the test continued. The complex, 3-part hatch was sealed, and the cabin atmosphere was purged and replaced with 100% pure oxygen, pressurized to 16.7 pounds per square inch, psi, slightly higher than the air pressure outside. The rest of the afternoon was a cascade of frustrations. The communication system was a mess, filled with static and garbled transmissions that made it nearly impossible for the crew to talk to the control rooms. At one point, an exasperated Grissom was heard over a stuck microphone asking, "How are we going to get to the Moon if we can't talk between 2 or 3 buildings?" The countdown was put on hold as engineers tried to sort out the issues. The test meant to be a smooth rehearsal, had become a perfect storm of technical failures. The Apollo 1 disaster was not caused by a single failure, but by a deadly combination of three fundamental flaws in the spacecraft's design and the test's conditions: a lethal triangle of spark, fuel, and atmosphere. First, the spark. The post-fire investigation found evidence of several electrical arcs, though no single ignition source could be conclusively identified. The most probable culprit was a section of vulnerable, silver-plated copper wiring located near the floor, under Grissom's seat. The wire's soft Teflon insulation had likely been chafed and stripped away by the repeated opening and closing of an access door, leaving it exposed. This damaged wire ran near a plumbing line carrying a combustible and corrosive coolant, a mix of ethylene glycol and water. Investigators later discovered that this coolant, if it leaked onto the silver-plated wire, could cause a violent chemical reaction, igniting the mixture. Second, the fuel. The cabin was filled with an astonishing amount of combustible material. Over 34 square feet of Velcro patches were attached to the walls to hold equipment in place. The very material the astronauts had warned was a fire hazard. Nylon netting, foam padding, and polyethylene tubing covering the wires all served as potent fuel. In a normal atmosphere, these materials are flammable. In the environment of Apollo 1, they were explosive. Third, the atmosphere. The decision to conduct the ground test in a 100% pure oxygen environment, pressurized to 16.7 psi, was the single most catastrophic error. While pure oxygen at a lower pressure of 5 psi was planned for spaceflight to save weight and complexity, using it at high pressure on the ground created an environment where materials that are normally non-flammable can ignite and burn with terrifying speed. It turned the sealed capsule into a pressure cooker bomb, waiting only for a spark. At 6:55 p.m., a momentary power failure was recorded, the first sign of the electrical short. 9 seconds later, at 6:31:04, a voice, believed to be Chaffee's, was heard over the communications loop, slightly strained. "Fire! I smell fire!" 2 seconds after that, Ed White's voice was more urgent and clear. "Fire in the cockpit!" What happened next was a horrifyingly rapid inferno. The fire, fed by the pure oxygen, spread from left to right across the cabin in an instant. On the closed-circuit TV monitor, watched by horrified ground personnel, a tongue of flame could be seen licking across the window. Ed White, following emergency procedure, was seen reaching for the hatch release. The final garbled transmission came just 17 seconds after the first alarm. It was a cry of agony, believed to be Chaffee, shouting, "We're burning up!" or "Get us out of here!" Then a sound of the spacecraft's hull rupturing from the immense internal pressure, followed by silence. Even if the crew had reacted instantly, their fate was sealed by the capsule's hatch. In a tragic irony, the design was a direct reaction to a previous incident. During his Mercury flight, Gus Grissom's capsule, the Liberty Bell 7, sank after the explosive hatch blew prematurely. To prevent a repeat, the Apollo hatch was designed to open inward. This created a deadly new problem. As the fire erupted, the pressure inside the cabin skyrocketed, pinning the hatch shut with thousands of pounds of force. It was a plug door, designed to be held in place by the pressure difference in the vacuum of space. On the ground, it became a death trap. The emergency procedure to open the complex, 3-layer hatch, required a minimum of 90 seconds under ideal conditions. The Apollo 1 crew had only seconds. It took the ground crew 5 agonizing minutes, fighting through intense heat and thick, toxic smoke, to finally get the hatches open. By then, it was far too late. The investigation that followed laid bare the shocking truth. The astronauts had not died from the burns, which were determined to be mostly post-mortem. They died from cardiac arrest caused by asphyxiation from the toxic carbon monoxide and other gases released by the burning materials. Their nylon spacesuits and oxygen hoses had melted, fusing them to the inside of the cockpit. The Apollo 1 fire was a brutal public reckoning for NASA and its contractor, North American Aviation. The investigation revealed a culture of go fever, where schedule and budget pressures had compromised safety, quality control, and workmanship. The tragedy forced a complete and painful overhaul of the Apollo program. The changes were sweeping and fundamental. The deadly inward-opening hatch was replaced with a quick-release, outward-opening design that could be opened in 3 seconds. The 100% high-pressure oxygen environment for ground tests was abandoned in favor of a normal, less flammable nitrogen-oxygen mix, and a revolution in materials science began. NASA led the development of fire-resistant fabrics like Beta Cloth, a Teflon-coated fiberglass, which was used to replace nearly all flammable materials inside the capsule. The sacrifice of Gus Grissom, Ed White, and Roger Chaffee was not in vain. Their deaths exposed the dark truth that in the rush to beat the Soviets to the moon, America's space program had taken lethal shortcuts. The fire was a horrific but necessary catalyst. It forced NASA to confront its failures and rebuild the Apollo spacecraft from the ground up, making it safer and more reliable. The lessons learned in the fire were paid for in blood, but they were lessons that ultimately made the journey to the moon possible. The Apollo 1 crew never left the launch pad, but their tragic deaths were the first, most painful, and perhaps most important steps on the path to humanity's greatest adventure. It leaves us with a sobering question. Is the pursuit of great ambition always destined to be paved with tragedy?